Yeah, we're live, 7:33. A little late today. Had an incident. I was already dealing with this. And then now I got this and this. So I had my backup, my spare tire. Oh, they're a little freaky. I need to go get some new ones. But today we're going to talk about, I've got some new packages, as you can see back here. We're going to undo those. We're going to talk a little bit about rocker ratio today. Because I have in one of the boxes, I've got, I'm pretty sure that these are rocker arms. And then I also have another box, a mystery box, the white box. Figure out what that is. Those are all Pontiac related. So we'll see what's going on with those and see what's going on with you guys. And make sure, let's get things started. Go get your projects done. Go get something done. List something on there that tells me that you got something done. I connected a red wire to a black, well, hopefully not a red wire to a black wire. I connected two wires together and I didn't even use a wire nut, which we've all done that. you probably shouldn't. You should use, solder and shrink wrap or something, and rather than twist them together. But have you ever put a stereo in, especially back in the day? Fold that over, tape that up with a little electrical tape, as long as it doesn't short against anything, that works just fine. And we put lots and lots of stuff in there, speaker stuff. Guys, we've had people come into West Tech that have used speaker wire to run the wiring for their fuel pump. It's really hot and it's way too small, and it doesn't carry enough current, and it's not a good idea. Just because you connect one wire from one thing to the other doesn't mean that it's the right one. And especially on a fuel pump that is going to have a lot of draw. And one thing that you don't want to do on something like that is on your fuel pump, you want it to have enough current because it has a lot of draw. Ideally, you don't want it to just have 12 volts. You'd like to have 13 or 14 or 17 or 20, which is how the Kenny Bell booster pumps, and now we're going off on a tangent, which is how the Kenny Bell booster pumps work and why they work so well. Because any sort of electric pump like that, when you increase the supply voltage to it, you increase the speed of the pump. And with a fuel pump, you increase the flow rate of the pump, which is good. Same thing with the water pump, and I did that on my Engine Masters motor. I had an electric water pump on there, and then we actually sped the water pump up using a Kenny Bell boosted pump. It was one of the tricks that I did to increase cooling. As it turned out, they overheated my motor for me by not turning on their valves when they started the motor up, because we got the motor up on the dyno for the competition, and got it started and ran it, and got it started, and they were running it and warming it up, and the thing wasn't warming up. And then I looked in there and saw water just spraying out. I'm like, you guys are overheating the motor. No, we're not. There's nothing wrong with it. I'm like, you guys, that it shouldn't do that. That's wrong. And what they did was not turn one of the valves on, because they had, when we had put it on, it wouldn't start, because they had hooked up the red wire and the black wire, which I was talking about earlier, on my MSD incorrectly, and they destroyed my MSD. So I had to quickly go over and borrow one from somebody else and hook the MSD up to the distributor and got it running. Well, when we were doing that, they had shut the valves off to supply water to the dyno, or to supply water to the motor. And so there was no water in. Well, there was water in there, but there was no circulation. And so then it started blowing all the water out. I'm like, great, you just overheated my motor. And as it turned out, they did exactly that. And my motor was kind of destroyed, because every pull that we made with that motor from that point on, the power went down and down and down and down. It still did well enough to make it to the finals. But like I said, every time we tried to make a pull, it just seemed to hurt itself more and more, because every pull went down in power from the last one. So my experience was not a good one, but it was cool to be there and to be there. But one of the things that I did is, because it was one of the tricks that I did while I was at West Tech, I wanted to see if more flow rate from the pump had helped things. And it did seem to. It's because one of the things that we were fighting is that we had to run on a specific fuel. I think it was 91 or 92 or 93, some kind of pump gas. And so you're balancing static compression and cam timing, dynamic compression and piston design and chamber design and all these things to try to eliminate detonation, because you could run whatever compression that you wanted, but they just limited the octane that you could get away with. So you had to play these games and making the thing not detonate, because you had to run it at, I think we ran ours from 3,000 to 7,000 or 2,000 to 7,000, and then you took the average power number. It might have been 3. So you had to make sure that it didn't detonate, especially down low. So you had to play those games. And one of the things that I did was increase the supply voltage to the water pump to get more flow rate going through there to hopefully cool it off more. And it seemed to help a little bit. So that's what we did. So that was my story on fuel pumps. But using the Kenny Bell booster pump on the water pump did that, and then also on electric pump on a fuel pump increases the fuel flow of the fuel pump. So it's one of the tricks that you could do that where you didn't have to drop the tank and take the pump out of stuff. You could hook up a booster pump, and instead of, you could have 12 or 13 or 14 volts going in, and then you could have 17 volts coming out. Or they had one also that would set things up to 20 volts, and you could have 20 volts going in, and then increase the flow rate of the pump. And the cool thing is you could rig it up so that it only did that when you were under boost, when you needed it. And then obviously you'd have to tune for that. But what would happen is you would just have more supply to the regulator, and then the regulator would bypass what you didn't need. So all that could work out if you had your setup done, and you could have more, because the fuel supply from the pump is obviously important, especially if you're in a situation where it's a boosted situation where you're rising, you have an increasing boost. And so the fuel flow that you're supplying, if your fuel pressure stays consistent, if it's 58 psi like on a typical LS, and you're running 20 pounds of boost, well, all of a sudden you'll now have the flow rate of 58 minus 20, so 38 psi. So whatever your duty cycle is at 38 psi on your injector, that's what it's now flowing, because it's a relative flow. So what most people do is boost reference the regulator, and then the fuel pressure supply to the injector goes up relative to the boost pressure, so that the delta pressure is the same. And so you still have the fuel flow that you would have had at 58 psi, which means more fuel, which means you can make more power. So when you do that, though, it makes life hard on the pump. So the Kenny Bell boost pump is one way to overcome making life hard on the pump. But we're not here to talk about that. We're here to talk about, let's see, we've got a poll going. Okay, so are you guys fans of the low buck chuck stuff? Do you use the low dollar offshore parts in your builds? So let's find out. And while we're doing that, we're going to take a look at some right here. These are from Speedmaster. These are the ones that they sent me for the Pontiac. These are rockers. I think that they're even roller rockers. I haven't opened them up yet. We have our box here. It says, "Welcome to the team." So let's see. So I think we have our little information sheet in here. Actually, the packaging that they did on this is pretty cool. So we have this. Oh, that's interesting. They even included an adjustable push rod. I'm sure that this is that's for checking push rod length, because it might be, and it's not uncommon, not just for these, but for any roller rocker, for you to change the required push rod length with the different rockers. This is a different ratio rocker. So on the Pontiacs, most of the Pontiac V8s, let's see, this has got to be a different length here. Oh, that one looks like it's actually the same. Oh, so they have adjustable ones on both sides. Look at that, fancy. So adjust there, adjust there, adjust there, adjust there. Although this is not, it's not a lot of adjustment Okay, we got a lot of adjustment on that one. That's good. Okay, so that's better. That's interesting. I'll have to give that a try. I like these adjustable push rod checker tools. Comp has a bunch of them. They've got a bunch of them at Westech. But on the Pontiacs, what we have here, so this, let's even see, here's the adjustable rockers. So roller, fulcrum, wah, 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 and a roller tip. This is not a guided one, meaning the tip, I like that the tip sticks down past the arm. I like that there's a, you can see here, there's a little slot for clearance for the retainer. If you've got a big retainer, which is pretty normal, it would be more unusual, I think, on a Pontiac to have a beehive spring. Not that you couldn't use that, you could, but for it to have a normal size spring. So this stops this from hitting the edge of the retainer, which is can be a problem. So we've got some your normal kind of poly locks for tightening that down. And then you saw roller tip, aluminum body, not terribly heavy. This, as you can probably see here, this is a 1:6:5 ratio. Normally Pontiacs are, a lot of guys, I remember getting comments on this when we were talking about the Pontiac stuff. A lot of guys think that all Pontiacs came with 1:6:5 ratio rockers. They did not. In fact, they are, the vast majority of them are 1.5. The 1.65s were used as a upgrade, and I think that they may have only come on the on some of the Ram Air versions, maybe just the Ram Air 4. The nice thing about doing a roller rocker like that, and more importantly, a higher ratio rocker, is that we're going to add lift. So I'll give you an idea here. We'll do a little math. So if we take a typical, let's take a 500 lift cam. So if we've got a 500 lift cam and we divide it by 1.5, that means we have a cam lift of 333.33. So if we multiply that by 1.65, our 500 lift cam now becomes a 550 lift cam. And so we can do that all the way up. So a 550 lift cam will become a 605 lift cam. So you're increasing the lift a good bit, about 50 thousandths on that, but you're also increasing duration slightly. So changing rockers can be beneficial in terms of power. Sometimes that's the thing. As we saw, I've seen this many times. We put rockers in, and especially going from, on a typical Chevrolet, you go from a 1.5 to a 1.6. On a Pontiac, a 1.5 to a 1.65 is a common upgrade. On a small block Ford, a 1.6 to a 1.7. On an LS, a 1.7 or 1.72 to a 1.8. You can increase because the LS7s were factory 1.8. You can increase the valve lift by doing that. And as I said, 1 or 2 degrees normally of duration is kind of the effective change if you map everything out. So you are getting a change. But I've done tests where we've added and changed the ratio of the rocker and added lift and a little bit of duration, and we don't see hardly a change in power. One thing that you will see, and we've done times when it does change power. So it's not a universal thing just because we've added more lift. And a good example of that is the information that Brian Tooley sent me. They ran, and this wasn't a rocker change, this was actually a cam lift change, but they changed their Truck Norris cam from their 553 lift cam down to a 500 or maybe even a slightly sub 500 lift version. And they lost very little power, a couple of horsepower, 2 or 3 or 4 horsepower. So it was almost nothing, given that big, fairly good size change in lift. I mean, it was a 10% change or so of lift in that case. But because the more important figures, at least on that cam, obviously, are the duration numbers, the LSA, the opening and closing points, all of that stuff. That's kind of what made the power. And so they got a very minimal change in lift. That's another example. And I've seen that when we've done rocker ratio changes, the same thing. On a small block Chevy, we'll take the 1.5s off, put 1.6s on it, and go, well, that really didn't do much. And a lot of times when we do that, we'll do 1.6s on, start with just 1.6s on just the exhaust, 1.6s on just the intake, and then we'll 1.6s on both of them and go, that was a big waste of time. That did nothing. And sometimes on that application, it did do nothing. It depends on the camshaft that you're starting with, whether or not the combination can take advantage of the extra lift. And a lot of guys think that they'll take the next step in their extrapolation and go, well, if the head continues to flow where the rocker is going to take the lift range to by increasing the rocker ratio, then you'll gain power. That also is not true, because when we were doing these changes, we're testing it on relatively mild cams, and we have cylinder heads that continue to flow at the higher lift ranges, and it didn't add power. I think it has more to do with exactly what the combination wants. But the thing that I would have liked running on this 1.65 ratio rockers, I would have liked to have installed these on the Trophy 4-cylinder. As it turned out, the cam was losing some of its lift and had very little to begin with. So it would have been an easy change to put those on to improve that really, really tiny factory camshaft to try to get more lift. And in the situations that I do see power gains from rocker ratio changes a lot of times are when we're doing it on a stock cam. And the reason for that is, if you take a look at an LS is a really good example. And I have a rocker ratio video up where you can take a look at the rocker ratio changes that we did, and roller rockers, because they're obviously you're getting a little bit from the roller fulcrum and the roller tip. But because an LS already has a roller fulcrum, which is where, in my opinion, the vast majority of the frictional change gain that you would get come from, not just the tip. The slider is a little bit, but I think that the fulcrum is the important part of that. But we did get gains going to a change in rocker ratio on an LS on a stock camshaft. And the reason for that is the same reason that we get such big gains going to a different camshaft on an LS, and any kind of camshaft, going from a stock truck cam, which is the mildest of all of the factory cams, to anything else, even other factory cams, but certainly aftermarket cams, little truck cams, bigger truck cams, NA cams, turbo cams, nitrous cams, whatever we put in there, we get big gains from. So basically what that tells us is that combination wants more cam timing. And so if we give it a little bit more cam timing, lift, and a little bit of duration with a rocker ratio, we do see a gain, because it's saying, hey, look, I want more camshaft. So even though you're not giving me a camshaft, you give me a rocker ratio that's almost as good. So I'm going to show you I have a good gain. Whereas if you put an aftermarket camshaft in there that already had 550 lift and 224 degrees of duration, you've given me most of what I want anyway. So going up in lift from there might be less of a gain. So that's a situation where I'm talking about on the rocker ratios, that sometimes you get gains and sometimes you don't. It's not a universal thing. I get that a lot, where guys, tell me, oh, I put this alphabet cam in a small block Ford, and now I want to change the rocker ratio. Am I going to get gains? You have to test it to know for certain. And luckily, I've tested a lot of those things and over the years. And like I said, it seems to be kind of a hit or miss thing with the rocker ratio. Although I'm excited about running these on the Pontiac, because like I said, especially on the mild camshaft, I think we would have saw something on the Trophy 4-cylinder if we would have had the motor was running perfect to begin with, which we should have before too long. So I've got another box here. You can see these are valve covers, and I know that they don't add power, but I really do like the way that these look. The reason I got these, or asked for these, is that these were on the 400, and they're kind of OG, like thinned aluminum, like the old Corvette stuff back in the day. But they do make the motor look really good. So I like these. I like these valve covers. And the nice thing is that these came with baffles and the breather grommets and stuff. they don't have the breathers themselves. At least I don't think that they do. They're not on this one. No, just more. No, just the baffles. Does it have two baffles? Yeah, it has. Look at that. It has. It came with both the baffles, both the breathers, and the bolts. So it actually came with everything. So I'm kind of liking that. Because when I deal with junkyard motors or free motors that people are essentially, it just means that somebody was throwing them away. And I said, oh, you know what? I would kind of like to have that thing that you're throwing away. And I'll try to make it run and see what happens. And then we can make it look nicer when we have that stuff. So let's see how our poll is doing. Do you use low buck offshore parts in your builds? 57% are saying yes, I would be part of that 57%. I use that stuff. I don't use everything. There are certain things that I trust and certain things that I do not trust. Like a roller rocker, I'm curious to see a lot of times the things, because we've got different situations. So sometimes I think things, I don't use them because we know that they'll break. A lot of, like, I don't trust offshore spring stuff, valve springs. That tends to not work. Sometimes the valve train, sometimes the valve quality and cylinder heads on some of the offshore stuff, we've had problems with that. So while I might trust a head casting, upgrading it with new valves and certainly springs might be a good idea. And then I would, if it has a history of bad seats, you'd also have to take a look at that. If it has a history of bad seats that they would fall out, I probably would avoid the casting and go to something else. Some things also going up in a step from that, some things may work for me on the dyno because we don't run it for 10,000 or 50,000 or 100,000 miles, that it may not have the longevity of a very few aftermarket products, I think, in my opinion, have the longevity of a factory piece. I would not expect a roller rocker from any manufacturer to last for 300,000 or 400,000 miles the way that a factory rocker does, for instance, on an LS application. I just wouldn't expect that. They don't put the time and energy and development into designing that part for that kind of longevity the way that the OEM does, because they don't have the money to develop that kind of stuff. They're not making that kind of money to put that sort of development in it, and they have to make it last a certain amount of time anyway, because they're warrantying it, at least at the OEM level it has to not break for at least whatever the period of their warranty is. And they usually are overdeveloped, so they last a really long time. As we've seen, I go get a 200,000 or 300,000 mile LS motor and then turn it into a turbo kind of race motor, and it still works. So that kind of stuff lasts a long time. And at the aftermarket side, I don't think that they do. But some of the stuff, that the low dollar stuff, I may put on there and run it for, 1 or 2 or even 10 dyno sessions, and it may work just fine because I'm only making 10, 20, 30, 40, 50 pulls, whatever that is. And even if it's a lot of pulls, even if it's 100 in one dyno session, relatively speaking to how many times it runs when it's driving around in the car, that's essentially nothing. Because a dyno pull, we may start the motor up and the dyno pull takes 10 or 15 seconds. It's just not very long in the grand scheme of things, not like running it wah 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 at a track or an event or that kind of thing. So the longevity part isn't really tested on the dyno unless, and Westech has done this, unless they specifically do durability tests. And those take a long time and are hard on lots and lots of stuff. But you have to do that, and the OEMs at that level, they definitely do that. So there's that, and then there's stuff that would break immediately. There's stuff that might last for the dyno test, but might not last for longevity in the car. And then there's stuff that might last for whatever periods of time in the car also, and then go bad. And then there's stuff like at the OEM level that lasts a really, really, really long time, usually longer than people own their vehicles. So there's different levels of that, and I try to choose those things accordingly. Like an intake manifold, that's not really going to wear out. It's not going to wear out you just hope that it fits and that it was machined properly. And then also that whatever they did, whatever thing that they were trying to duplicate or emulate's a really nice word there, whatever thing that they were trying to aspire to, that they did a good job in making the performance be there as well. So if they're trying to do an air gap or a single plane or whatever they're trying to do, that they did that, and that it also hopefully adds power compared to whatever stock thing that you were trying to replace and upgrade it with. So that hopefully that it has that. So a thing like an intake manifold, carburetors, I kind of, if I'm going to get a carburetor, an OEM one like a Quadrajet or something, or a Holly. There are obviously some smaller carb guys out there that do good stuff as well, but I don't know if I've ever tried an offshore carburetor. Distributors, although I don't trust them, I've run lots of them, and they've they've actually worked fairly well. I don't know that I've had one go bad. Camshafts, I know that there's a lot of inexpensive camshafts out there, and some of those I've seen have been tested, not just for power, because again, it may work for the engine dyno, but if you actually do metallurgy tests on them, the hardness is not very thick. The machining on them is not terribly accurate from lobe to lobe. It would be interesting to see if when they did the grind, how close it is to whatever grind that they were trying to emulate. Is it really close? Are the valve events exactly right? Was it ground with the locating dowel in the right spot, and then all of the lobes off of there, are they in the correct position? Are the lobe shapes the same? You know, there's a lot that goes into making a camshaft. And then is the finish good? Is the longevity good? All that stuff. So that would be interesting to test that stuff. But the problem is the expense that you'd have to go to test that doesn't really justify the information that you'd be providing, maybe. So let's see how you guys are doing this morning. Hopefully you got your projects going. Do you use low buck offshore parts in your build? 55% are saying yes, and 45% are saying no. So let's see what you guys got going on. Richard, can you do a rocker ratio test with a mild cam to see if it's even worth it? Can you also show the relationship between high ratios and valve flow? That's an interesting point. It's one thing that I started to talk about and then got sidetracked. One thing we do see on tests, putting for instance, if you take a small block Chevy or small block Ford and take a stock stamped steel rocker off and put a roller rocker on, if you don't have enough valve spring, you're going to get into valve flow. We saw that with the LS stuff immediately when you go from a stock rocker, because their rockers are fairly light and very efficient, and they're also a roller already. But if we go put a much heavier typical roller rocker on there, like an aluminum bodied version on an LS, if you try to do that with a stock spring, you will definitely go into valve flow. If you try to do it with some of the aftermarket springs, even, you'll get into valve flow. You need more valve spring with a roller rocker on an LS application, and also on a small block Ford or small block Chevy. Any of those applications, the roller rocker compared to the factory stamped steel one, definitely. There are some heavy factory rockers, like some of the Fords were like that, where you'd need enough spring even just for that. And then changing the ratio also affects that. So make sure if you're doing a rocker change that you definitely have enough valve spring. You turn on the cars and cameras. I'd rather get used injectors from a wrecking yard. Yeah, and any injector that we would get, luckily Westech has that ASNU machine, and we could check them and clean them if that was necessary. Chinese LEDs are hit or miss. I use an Eagle crank. The cranks and stuff, I've used lots of Eagle and Scat and these various manufacturers of both cast and forged cranks, and same thing with connecting rods. I've used that stuff a lot, and I actually have always had good luck with it, as long as it's right. Turbos also are I've used lots and lots of offshore turbos, and all of the ones I've used so far have been good. Almost bought some valve covers like that for my Cutlass, but they say Oldsmobile down the middle. I saw some in person, and the cast quality was not good. I didn't buy them; they were $300. I was surprised at how expensive valve covers were when I went to look. I ran 1.8 rockers on my 4.8 with a 216, 220 cam. Or you only pick up 1 horsepower. Yeah, sometimes. So, nerd, you didn't like the parts for your WRX, for your Fox body? Oh, they're okay for the Fox body, but not for the WRX. I deleted a bunch of stuff on my MR2 and plugged mounting holes with aluminum buttons. I prefer to use US parts. It would be hard to find parts anymore that are designed here and made here and cast here and machined here anymore, because it's just not, it's hard to be competitive. LS rockers and lifters, definitely not. I'd rather use GM junkyard parts. I'm a big fan of the factory rockers on the LS application, particularly because they're very, very good. They have a roller fulcrum. I know they slide on the tip. I'm not worried about that at all. Guys have taken them to 8,500 RPM. They last a long time. They were their OEM quality. So I really like those. Let's see what people have going on. I have a 255 pump and a stock 302 turbo factory wiring. A 255 will probably support a turbo factory 302. Finally got my H22 pulled out of the Prelude. Good. I'm talking the built H22 I had for my Civic and dropping in later. I'm going to go K series, all-wheel drive in the Civic. That'll definitely help traction. You ever tested the Hooker small block Chevy 2.5-inch exhaust manifolds? Is the opening 2.5-inch? I haven't, but if the opening in the exhaust manifold, and hopefully they did the internal port exiting, where the manifold attaches to the head, hopefully that's good size. That should flow better and make a little bit more power compared to a stock one that would be smaller. They just won't do, they're not going to do what a long tube header does, because they're not going to have the scavenging effect. Big John, we're taking questions from every seat. Richard, did you see the new Super Duty? If that's a truck, I haven't looked at trucks. South Texas is here. The morning motivation show. Okay, I can scroll back down and see where people are. Are you leaving? All right, have a good day at school. Let's see. So no on injectors. Anyone else have a comp cam solid roller T-bar fall off? I have not. I've never seen one fall off. Did it break? I mean, it can't just fall off. It would, because it would have to it'd have to reorient itself to slide off of the other bar. How was it attached? Were they riveted on? A lot of them are just have a rectangular slot, so you have to put it on in one orientation and then rotate it down, and then it can't come off, and then that's how you hang the other one, and then you put them both in. The ones that I've seen are like that. So did it break? Did it contact something? Jessel and T&D don't seem to concern themselves too much about pricing. Do you think they'd hold up over the long term under 240 pounds of seat pressure, 550 open? That doesn't seem like very much open pressure relative to the seat pressure, but I think that they work. Those are both good quality pieces, but they're not designed for an OEM level of thing. They're not designed to run 300,000 or 400,000 miles, because nobody's going to run the motor that you would put that stuff on that long. I mean, drag race motors never last that long. Running 7-stage 2 high lift truck cam and a 6-liter LQ4, wondering about timing. What kind of timing do you think I can get away with? Your timing is probably not going to change with that camshaft from where it was stock. When we run the stock cam, we run about 29 degrees of total timing, because that's where it makes best power. When we put another camshaft in it, it still wants about 29 degrees of total timing. The thing that you might change with the camshaft is detonation sensitivity. Maybe you've changed your your all-important dynamic compression a little bit. But that's something that's going to have to be tested to know what the detonation sensitivity is on your 317 headed LQ4. Are you planning on running the 274 cam on a 302 with the Enforcer 185s? We might try different cams. I don't know exactly what we're going to do with that. Oh, it wasn't peened over properly? You should do a video on LS oil systems and pumps. I think the guys at Westech and Engine Masters just did an oil pump test where they tested the standard volume and high pressure and high volume, and high pressure and high volume. And they were demonstrating the oil pressures delivered by those, and then also the power losses associated with driving more oil pump. At a comp retrofit rocker, have the pin from the roller back out. I'm starting to suspect high pressure fuel pump failure. I won't even start unless you spray half a can of ether at the filter. So did I miss your other comment farther back up here? I need some help. We're smoke check this entire motor. I can't find any intake or exhaust leaks, but it's the same symptoms as a worsening vacuum leak. It does sound like a fuel system problem. Girdles for valve studs? You mean the rocker studs? Is that what you're talking about? Those will stop deflection in the plane that they're designed to do that for. But the question is, do you need that? It'll also stop them from backing off. You want tungsten rocker covers? It's raining there, Gabe. Usually my builds start out as a simple, cheap Chinese parts and then slowly evolve into high dollar builds. Looking for small block Chevy beat up aluminum heads. Gabe, I'm going to take a look down at West Tech. I think that they might have some, maybe they have some old L98 heads or something like that. One fast duster. Let me scroll back up and see what his cam question was. Okay. That's not it. As far as cams, I used to look into all the little specs and details for turbo applications. I just try to find a dyno graph of a cam and see what curve I'm looking for. That's a good idea. The camel humps would be better than your 84 Chevy 350 heads, but not significantly better. Richard, using a factory 5.3 and an eBay GT45, what's a good spring upgrade if needed? You're only to run 10 pounds and you're going to run the stock cam. You could do that with you can run the stock spring with a stock cam, even under boost. Because you're not going to be running a lot of RPM with that cam either. When does it become necessary to run rocker girdles? If you have 3/8 rocker studs, you don't need to worry about girdles. Titanium rockers? I've never even heard of somebody making the rockers out of titanium. How do you guys feel about Michigan Motorsports? I've not heard of them, so I'm the wrong guy to ask about that. I wonder what the strength to weight ratio on titanium rockers would be compared to aluminum, though. I wonder. I wonder, who. 54% saying yes and 46% saying no. Do you use low buck offshore parts on your builds? So glad somebody out there that somebody answers questions. Saving money helps. It definitely does. Fox and Freedom, do you recommend rocker girdles on 7/16 studs on Motor Trend 6500? I never run them on something like that. So Chrysler 906 heads. Is that a big block Chrysler head? None of the wedge heads, the factory wedge heads, flow anywhere near what a big block Ford or a Cobra Jet or Super Cobra Jet or Cobra Jet Ford or a rectangular port big block Chevy head flows. A big block 440 or 383 head flows more like what a small block head flows. How do we donate to your efforts? Well, you can do super chats would be one way. Do you do your motivation live streams and getting more projects? I'll keep doing it. So if we have twice the strength and 60% of the weight, or 60% heavier, would we really be gaining much by going to a, could we make that rocker lighter? Maybe if we did the design correctly. Rocker stud girders really only need with very heavy spring pressures. Yeah, you're looking for the spring pressure to deflect the rocker stud, and it has to be fairly significant to do that. Car projects are put on hold due to hurricane prep. Yep, lots of guys back there in the Florida area are going through that. Wish I could find some trick flow heads for my 448. So excited. I have a 76 350 I'm building, also a small block Chevy, and my 84 C20 is experimental vehicle. Richard, can you explain how and why cam manufacturers place different LSA numbers on different durational lift cams? What you're asking is why do they make different cams? They make different cams for different applications, and the LSA is going to be one of the things that they adjust to make the cam do different things on the motor. Is there too much rocker ratio? Yeah, there is. Did a 185 help you on the big block as opposed to a 1.7 or a 1.72 that would have come on there? Is there a conversion kit to put a small block Chevy in a Durango? Well, adapting the Durango trans would be difficult, but you would just put a small block trans in it. So Admore, you did a compression test and that's all even. That's what you want to see. Richard, have you run a supercharged small block Mopar on the dyno? I have not. I'm wondering how much power the stock block will hold. More lift and more duration is always good. It just makes the thing less drivable and maybe make more power on the top if you keep adding cam timing. But there would be a point where you stop gaining depending on what the rest of the combination is. What is going on with all the BTR shaft rocker failures? I wasn't aware that was a thing. Richard, there's no off topic because there's it's not a designated topic zone. So you can ask whatever question you want. What do you think the best cam is for a stock bottom end 302 GT40 P heads, headers, GT40 intake, 24-pound injectors, and a cold air intake? There's like 50 camshafts that you could put in there that are all going to be doing kind of the same thing because you're limiting yourself with the head and the intake manifold on kind of where it's going to make power. Anything from that 274 comp extreme energy cam, depending on you have to make sure that you set the P head up so that it has enough valve spring in it. but any of the new Summit Alphabet cams or the older Alphabet cams, any of those, I like dual pattern cams more than I like single pattern cams, and a lot of the original B303 or E303 cams, those all work, but I think that there are better versions of that. I used to have two sets of Speedmaster stainless rockers on a small book Chevy. I had to remachine the saddles both times because the rocker geometry is not correct. That kind of thing definitely needs to be checked. Racer D, you're right. Richard, how much RPM do you think a 302 F2TE forging number rod? I'm not familiar with that forging number on the rod, so I don't have any idea. You have to tell me what application that came from. Have you ever notched pistons using a valve cutting tool with the drill? Yes, I have a couple of times. I did it on a big block. In fact, I think I did it twice on the big block. It was a big block Ford because we tried running. The crate motor had Cobra Jet heads, and then we wanted to try the Super Cobra Jet heads way back when Lingenfelter did those. Or rather, Kazi did those for Ford, and we wanted to test those, but the valve was in a different position. So we cut those, and I think that I have notched a couple of the Big Bang motors. I notched the 351, and I've done another one. Maybe it was a big block, and I used cutting tools on two of those, and one of them I just used a Dremel, just marked it and just put a little slot for the valve there. Have you seen any stock bottom end LT port injected motors make 1,000 horsepower? You mean changing over? Are you? I'm a little confused on what you're asking here. Are you talking about a newer LT motor, the Gen 5 motor after the LS? If that's the case, then are you talking about converting it from direct injection into port injection? And then are you asking if that can make 1,000 wheel horsepower? The rings that I know of are not soft. I don't think that's how I would do it. I would make the ring gap correct for running boost on those. And guys I know on LT motors have made more than 1,000 horsepower with them. Would you know off the top of your head what would be a great set of springs for the P-heads? I don't know. I don't have a part number for you. Trying to scroll back, and I was trying to find another comment. I don't see it now. I have a Cam 306 small block Ford with no markings, only a very small, what looks like to be a G. I forgot the exact lift, but it was bigger than 530. Any ideas? I don't have any idea. Richard, how about doing a test where you open up rings up nice and wide and show there's virtually no power loss? You mean like I already did on all of the Big Bang motors? F2TE rods are 92 up truck applications. So it's a That's probably the same rod as a, isn't that going to be the same rod as a 302 HO motor? Richard had me running 277 intake, 292 exhaust at 50, 847 left in a twin turbo 496. I can't wait until the Dominator gets direct injection support. Why aren't V10 swaps more popular? There aren't a lot of parts available for them, and they're big and heavy, and they don't make very much power. They are cool though. Gabe, your 04, is it a 5.2? Is it a 4.7? What is it? And if well, either one of those can make power. We've run on stock stuff. We've run I don't know, mid 600s, I think, with blowers on them. Richard, are you going to be testing the new Edelbrock carburetor? Yeah, I probably will. Brule probably has already done that. Sierra, I wouldn't know what the difference is between stock retainers and keepers on the springs that they use on the GT40 heads and the E7 heads. Will ARP sell you a single head stud? I think that they will. So we'll close out our poll at 55% saying yes, they use these parts, and 45% saying no, they don't. Do live chats pay the same as videos? The viewership of live chats are never nearly what they are for the other videos. Hot mess. You're using a word there that I don't like. It's triggering me. I don't identify as the word thoughts. Will a V10 bolt up to this? Gabe, I don't know. I don't know your swapping stuff on the Dodge. One more minute. Hot mess. I don't know how much power you're trying to make, but that camshaft in a 496 is a huge, like, NA style camshaft, and you don't need anywhere near that much camshaft for twin turbo applications, unless you just want chop in it. You could have 20 or 30 degrees less duration than that camshaft and still make, I don't know how much power you're trying to make. Are you trying to make 1500 or something? You could easily make that with a much, much smaller camshaft. What is the RPM ceiling on 302? I don't know. We typically run them to 6,500 or so. And I'm not saying that they won't go more than that. But I just think if I was building a 7,000 or 7,500 RPM small block 302, that I would buy cheap forge rods for it. Yeah, I figured duration was going to be an issue with that. It definitely will be. That's a really big camshaft. I mean, it's a good camshaft for making NA power. It's the kind of camshaft we would run in a 496 if we were trying to push power up near 800 horsepower. It might even be a little bigger than that with a tunnel ram and stuff, and really good heads, and lots of compression. But it's not anywhere near the camshaft that I'd use for a twin turbo deal. Not that it's not a turbo camshaft. You can run boost on it. It's just that you don't need to get the other things that we talked about at the lower part of the scale. You could get better drivability and better idle and stuff and better boost response if you had a smaller camshaft in it, a smaller version of that camshaft, and still make all the power that you want, because the turbos are going to dictate that. They are. All cams are twin turbo. John, you're going for the stock bottom end 302 record? I think that number is up there pretty high. I thought somebody told me that somebody was doing 900 with one of those. I learned a ton from watching your video. 69 C10. That's a good one. Toledo, Ohio. I was in your area not long ago. Well, I'm thinking that I was. I was in Ohio anyway. Yep, everybody go out and get your projects done. I have to take all the stuff back down to the garage. Stock bottom end 302 NA record. I don't know. I have no idea. Does anybody know? Does anybody answer? Big John, he's going after. If you're going after record, that's really cool. It's going to be, to make power on an NA motor, it's going to be RPM. I would imagine it's going to be RPM limited, because there's lots of good heads that you could put on that. You could put really big camshafts in. You could put a tunnel ram. You could put all that stuff on there that you would want to do on a stock bottom end. If you're only concerned about the stock bottom end, you're going to be limited in how much compression you can get, and you're going to definitely be limited in piston to valve clearance with that. What's your favorite set of full roller rockers for a Vortec 350 with press-in studs? You shouldn't do that. Richard, are you going to go to the gym today? No, I don't have a gym membership. I have stuff here, though. Admiral, that seems like a really long message on a shirt. The next dyno testing that I do might be the Pontiac 350. There'll definitely be some LS stuff. I need to do more Ford stuff. I have more stuff. I have more stuff than I have time to do. Have you ever eaten microgreens? No, I haven't. I'm not even sure I know what that is. My Trail 90 definitely needs a turbo, or actually an electric supercharger is kind of what I'm planning. And on that note, it's time to go. Thank you guys all for showing up. I will see you tonight, and I'm working on a video right now, well, after I get off here, as we speak.